Hey, what's up, everyone? I hope you are doing well. Welcome back to part 2 of our perfume bottle series. I'm just starting in a new scene of Houdini here, and all I have here is the perfume bottle that we created last time. I have a few kind of split nodes here where I've just split the bottle up, so if we wanted to render it, we have it split up, as well as we can use this when we're doing simulations. We can just grab the piece that we need. So in this tutorial, we're going to kind of break it up into several different phases, and you can see the time marks on the YouTube link if you want to kind of jump around. But we'll start off with just a basic Falloff and inflation. Then we'll take a look at using pressure instead of wind, and then we'll look at different ways that we can run the Falloff so that we can get different results. So let's jump in and let's get going. I'm going to start and just create a geo container, and this is going to be our Vellum working. Make that yellow, and let's jump inside. And the first thing I need to do here is I just need to grab our bottle, and I don't need the labels, so I'm just going to grab these two over here, and I can just copy both of these with OD tools, come in here and Control Shift V, and it'll bring them both in here, and hold Alt, and I get a merge with both of them. So here we have our bottle, and what I'm going to do here is I don't want the inside mesh, and so in a very quick way to kind of get rid of that is just drop down a clean node, and then I'm going to subdivide it so it's nice and smooth, and then I'm going to use a remesh to grid. And obviously that is too low res. All right, so something like that looks pretty good. So this is the before and the after. So you can see that it's a very similar shape, but now we have nothing inside, and we have kind of nice uniform topology here. We can also run a remesh if we want this to be kind of a lot lower res if we need that. So we can kind of just keep both of these here, and depending on what we do with this in future tutorials, we can kind of use these as we need to. There's also the poly reduce, which is quite useful to kind of get the exact same topology, but it does reduce. You can see here in these long sections, it does a good job, but it maintains the geometry everywhere else. But I don't like these long triangles here, so I'll get rid of that, and we'll kind of use one of these two. And I think this is close enough if we want to use a collision mesh. So for our inflation, we're going to use a grid, and we want it to be on the X, Y plane. Let's just take this out. So we don't need it to be so big, maybe a value of 3 and 3. So it's a bit bigger than our bottle. And the next thing I want to do is I want to just make sure that it's always aligned to our bottle. So we can just use a match size, and we can just grab this here. And so now our grid is kind of in line with our bottle. So let's give our grid a few more subdivisions. Doesn't have to be too crazy high for now, as you will see why in a second. We're not actually going to use this resolution, but for what we're going to do to get the cool shapes, some resolution does help. So what we're going to use is we're going to use a Voronoi fracture, and we're going to scatter some points onto our grid, and we don't want so many. Let's just go 4. And it's kind of hard to see because it creates this inner mesh, which we don't want. So we're going to get rid of that interior surfaces so we don't get that like weird glitching. And now we have this. Now, if we increase these, you'll see that we get a very Voronoi pattern, which possibly that's what you want. But I wanted to get something a little bit more fun and a little bit more organic. And there's a couple kind of cool ways that you can do this with the Voronoi fracture. But what I want to do here afterwards is just add a divide, and we're going to remove shared edges. So now we get just the Voronoi fracture, and then we can add a normal node just to get proper normals on here. So this just makes it easier to see the end mesh that we will end up with. So the trick to get this to work is first we need to add a rest node. And so we can reference this back. And then at the end here, we're going to add another rest node. And this one's going to be extract the rest. So we can just write here, extract and store, just so that we know what these nodes are doing. And now if we do anything inside here, so let's start with an attribute noise. And actually we can just use a mountain. So if we have a look here, you can see that it starts, we don't want to move it along the vector. Okay, so something like this looks pretty good. I'm going to come in here and just change this to standard and like this. So now it's really warped it, but now we have this extract rest, and so it goes back to normal, and you can see our normals get messed up. That's why I added this normal node. And now you get these really cool patterns, and if you come in here and you adjust things, you can see that you get really fun, like crazy results, but it just breaks up that mesh or that Voronoi pattern so that it doesn't look like that. And obviously you can do all sorts of things, like you can transform it. Let's just set this to be the center. I have this little expression here, and now you can kind of scale it, and you get all sorts of like super cool stuff. So this is just to keep in mind. This is a cool way to get fun meshes. I'll leave that over here, but we're actually going to use a twist. And what we want to do with this twist is we're going to use a mask from geometry. And I want to do this up top here. And now we need a geometry. And what I'm going to use here is I'm going to use an extract centroid. So I'm going to set this to detail, and we'll use bounding box or center of mass. I think they're going to be the same thing in this case. So if we have a look at our mask attribute, we change this to maximum distance, and we set this to be on points because we know there's a point coming in here. Now we have this cool 0 to 1 attribute, and we actually want to invert it. So we have this really nice 0 to 1, and we can kind of do this procedurally because we're using this point, which is in the center of our geometry. So this is a cool way. If you use a pig head, you can do the same sort of thing. So now you know that this is going to be the center of the geometry outwards. So it's a kind of fun little neat procedural way to get a nice center out gradient. And in this twist node, what we're going to do here is we're going to scale by attribute, and here we can just use our mask attribute. So we need to set this to be on the correct axis. You can see here. So let's just move it back a little bit. And this doesn't have to be so long. So let's go -2. Okay, something like that looks pretty good. This is not centered, so we want to make sure that it is centered. So our grid is up there. So another cool kind of procedural way to get this centered is we can say the centroid, and we want to use the centroid of the incoming geometry, and we're going to use the d_y. So now it will always pick the center of the incoming geometry. So if we disable that, now you can see this is in the center there. And the other thing we want to do here is we want to take the length, this capture length. We're going to copy this parameter. We're going to paste it here, paste this relative reference, and we're just going to divide it by -2. So now it will always sit in the middle. So no matter how long we make this, it will always be centered on our geometry. So that's another kind of cool procedural thing that if we change anything, this will change with it. And I find that these kind of things are really important to set up as you go along and not just manually do it, because when you change your grid size or something up above for a new project, or you want to try something, everything breaks. Then you end up going through each node trying to find what breaks. Whereas if you set it up procedurally as you go, it just ends up working a lot better. Okay, so let's do something extreme here. 500, and you can see if we don't scale by attribute, it's just going to rotate the whole thing. Whereas if we scale by attribute, now the edges are more scaled than the center. And if we jump to the end here, let's turn off our mask attribute. You see we get this really cool swirly behavior. And maybe this is too much. All right, so you can also come in here and play with this. I'm going to set this to be linear. So we get quite a linear fall off. And you can see if you scale this in, this is Voronoi, this is now our other pattern, and you can do it the opposite too. So you get this kind of swirliness here, and then here it goes back to Voronoi, and you can kind of play with this, and you get quite a lot of control, which is quite fun in this kind of setup. So anyway, I'm going to go with something like this. Like this is pretty good. And we'll have our bottle in the middle here, and we can kind of preview it. And maybe we want a few more points for this so that we have a few more segments. Let's maybe go with 65. Yeah, okay, so that looks pretty good. And you can make it more or less depending on what you want. And you can also change the twisting to kind of get less of the Voronoi. And you can also add in a mountain in here as well, and then you get some really cool like warped things. And I didn't actually think about this for when I was doing it, but I do like it. It's pretty cool, but we'll leave it off for right now. So the next thing we want to do is we want to remesh this, because if you have a look here, we have no points in the middle here. We just have outer points. There's no mesh here. It's just a single end-gun. And so we're going to make this quite high res. I think that's good. We're getting a lot of stretching here. So what we can do here is just increase the smoothing iterations, and maybe just increase the smoothing a lot too. Okay, so now we get a lot more uniform triangles. Something else that I find with a setup like this, where I know I'm going to inflate it, I want to get those nice wrinkles on these edges here. I'm going to add a resample node, and this usually works on curves, but you can also resample lines like this. And you can see here, I am resampling these edges, and I'm going to make the edges quite low. All right, so there's a small gap here, so we can maybe go even lower. Okay, I think that's pretty good. And what we get when we remesh with a resampled edge is you'll find that the edges get a little bit more high-res polygons. And so because Vellum is a point-based solver, because these edges are more high-res, they will get a few more wrinkles. It's just the way that Vellum works, and it ends up looking really cool. So you see you get something like that, and that's a bit too much. So I'm just going to jump this back up to 8. Okay, yeah, I like that. So it's just a little bit more geometry on those edges. Okay, so before we forget, let's use a UV project. Always get UVs in going, then you have them. Okay, so we have our UVs, and we can now use a group node, because we're going to want the edges of these groups in Vellum, and so we can get that with unshared edges. Because these are all separate pieces, we can use that. And the next thing I want to do here is just add a connectivity. And now if we have a look at our class attribute, we have a different color for each piece. Now, these nodes are nodes that let me just name this. These nodes are nodes that I use often in projects, so I'll kind of just do them by default and I have them. I may not even use the class attribute, but I feel like it's good to have and set up before I simulate, and then afterwards I wish I had it. They're light enough that they don't, cause a huge difference in sim size or simulation time or anything like that. So I just kind of put them up there. But I do like having this class attribute, especially for rendering, because then we can add different colors to things and it makes it look a little bit cooler. So the next thing I'm going to do is just use another match size. And I want to make sure that this grid is lining up to our bottle over here. And the main thing I want to do here is I want to make sure that this grid is behind the bottle, right? So before it's right in the center, now it's behind, and I can actually just move it maybe a value of 0.025, so it's just behind the bottle, maybe a little bit more. Yeah, so it's a little bit behind, so it can inflate and fill in around the bottle. All right, so the next thing we want to do here is just create some Vellum. So I'm going to use a Vellum balloon, but I'm not actually going to use pressure for right now. I'm just going to use cloth for this initial demonstration. I'm going to pin the edges. They're going to be permanently pinned. And for this one, we can maybe make it a little bit more stiff, maybe 3000. We want a lot more dampening so that as this inflates, it's kind of a little bit more stiff. And I'll show you how you can obviously change these settings to make it less stiff. And then I want a lot of bend stiffness so we can kind of get those wrinkles that we want. And then I want a film solver. So let's jump up to 3 substeps. We'll turn off gravity. We'll probably have to put in some velocity dampening in the future, but for now let's leave it as is and let's see what we get. So if we hit play now, we have a Vellum simulation, but nothing's happening because we have no forces and we have nothing going on here. So let's make something happen. For this base simulation, we're going to use a Falloff to drive our wind as well as our rest length on our stretch stiffness. So let's quickly create a Falloff. We'll use a mops spread Falloff for this one. And I'm going to use a sphere. And let's just make this way smaller. And we can use another match size. And the reason for this is I just want to get this somewhere in the center. So I can kind of center this and then plug it in here. So you can see that the sphere is centered, and then I can set this to point cloud. And now when I animate this up, we get this growth. And again, it's just procedural to set it up like this rather than picking a point. And we can just apply some noise. All right, so we get, so let's just keyframe this. And maybe after 100 frames, this goes there. And we don't need this to be so long. I'll make it 150 frames. All right, so we have this cool fall off coming through, and we'll create a null. Call this out mops. Okay, let's jump into our solver. Okay, I'm going to turn off simulation so I don't keep trying to simulate. Okay, so what we first want to do is we want to create a pop wind. And we're going to set this to a value of 5, maybe 6. And let's hit play. All right, so you can see that it's kind of pushing the cloth forward, and we get this nice rounded bubbly look. So that looks good, but obviously we're not getting wrinkles, as well as it's not being driven by a fall off. So let's first do the fall off part first. So we can use a simple pop wrangle. And what we want to do now is we want to fetch that mops fall off. So I'm going to just fetch that over here, and I can use these dots like this. I need 4 of them, and then I'm in the right context to fetch out. And here I can just do a very simple expression. I can just do f at fall off. So now I'm writing my own attribute inside of dops, and this is just going to be fetching that mops fall off and the PT num. Now, I don't have to do anything fancy with this because my point count is remaining the same. I'm looking up the exact same point numbers outside as I have inside, and I'm looking up this point and I'm writing it to this fall off value. So now in this wind function, you can see here this is called wind. So I can just say wind is times equal f at fall off. So now if we hit play, so now you can kind of see that it's slowly growing on with our fall off. So the wind is only being affected by the points that mops is allowing it to be affected. So it has the strength multiplied. So 6 multiplied by fall off. So where fall off is 1, you have a value of 6. Where fall off is 0 is 0, and everything in between. So you get this kind of nice fall off. And if you wanted it a little bit more hardcore, you could also just come in here and remap this fall off. But for now, we'll leave it as is. And let's just get rid of that bottle. All right, so now we have that fall off. The next thing we want to do is just get mops, is we want to do the rest length of this stiffness. And just to kind of show you what that'll look like, if we increase this to 2, this is the rest length here, and we hit play, we can just pop 1 frame forward because this will happen on the first frame. This is not done by a fall off, but this is just done on the first frame. It will change. So you can see now what this is doing is it's increasing the rest length of these pieces, and it gets a lot more wrinkly. So if we disable this, so you can see now we get a lot more wrinkles and you get this nice puffy look. But again, now we don't have the fall off. So let's add back in our fall off over here. We can turn this back to 1, and we can now dive in here and we can set up a wrangle to do that. Now I've done this many times before, so I'm not going to do it in depth. I have several other Vellum tutorials, these ones over here, where I kind of walk through this line by line. So here I'm just going to quickly do exactly what I've done before. All right, so yeah, you can go check this out, but basically I'm just grabbing the mops fall off and I'm setting it to these values. Now I've got a min and a max. So I'll set the min to 1 so that where it's 0, it's not being changed. And then the max we can set to a value of maybe 0.6. Again, we just want to work on the stretch and bend. And we want to make sure this is set to primitive. Now, some people have been asking about how to save these. So I have a shelf here, which I call my tools. And all you can do here, and my shelves are looking different. If you want to change these, you can change here and you can display them as different things. I just drag mine up here and then it sets it over here, and you can delete it. I don't need this one. But I have a Vellum get attributes. So if I say Vellum get attributes, that's saved up here somewhere. And it's exactly the same thing where I have kind of a preset of this, but here it is here. So now with that, if I hit play, let's actually create a camera and flipbook this so that we get something cool. Camera. And let's go back. Let's jump into our camera. Oh. And I'm going to set this camera to be square. That's what I've been rendering these as. All right, so something like that looks pretty good. Maybe a little bit of rotation. All right, so we have that. Let's jump back into our Vellum. And let's do a quick flipbook and see what we're looking at. All right, so this is what we have at the moment. You get this kind of cool growing on inflation. Something that I didn't like once I had done this was it kind of looked like a dissolve effect where you were kind of dissolving or cross dissolving in After Effects or wherever, where it has this kind of smooth. And so possibly what we want to do is just remap this Falloff. And so I never actually tried this, but I will try it now that I have you on the stream. So let's just kind of clamp this a little bit. So we have a less kind of gradual Falloff. We can go quite hardcore, something like that. And let's see how that feels. The other thing I want to do is I want to bring in our collider over here, just so that when this inflates, it kind of inflates against our perfume bottle. So now we have our collider. Let's turn off our Falloff and let's just quickly do another flipbook. So I'm not sure if this is better or not, but I mean, it is different and it's kind of cool. It's not as cross dissolvey, if you ask me, but this did lead me to then kind of wonder, okay, how can I kind of get something that's a little bit more art directed? And this is where I ventured into kind of different Falloffs and how we could art direct them. So let's take a look at the next iteration of this process. All right, so I've just duplicated the same setup again. Everything is what we had before, and we'll keep everything as is. We will eventually change the actual Vellum simulation, but for now we'll keep it. And we'll just keep this node here, but we're going to get rid of the actual Falloff. And we're going to be using a new MOPS node called the Infection Falloff. It's a new node and it's a part of the plus. So if you don't have plus, then you can kind of just skip this section. It's basically an infection solver, which allows kind of updating incoming sources, if you will. So let's take a look at how we can set that up. So I just need to make sure that my start frame is set to 1001. And then if we take a look at it, nothing happens because we need something to start it. So we need an infection point. So if we add a sphere here, and let's just make it smaller. Now, when we hit play, you can see that it grows and it has this super cool organic growth. And you can change the size of this. Let's just steal this so that it's centered as we had before. And we can change the size and hit play. And you get this. This is the default behavior and it's pretty cool. Now, obviously, this is not what I want. I want it to kind of follow the tracks of each of these different pieces. Let me jump out of our camera so we can see. Okay, so there's the different pieces. And I want this to use the connectivity. So it actually has a connectivity section here. So I'm going to say spread by connectivity. I'm going to turn the spread radius all the way down. And you can see now that it fills just that box. So that's what I want. But now obviously I need pieces everywhere. So this is where I started kind of venturing down this rabbit hole. So let's tidy this up. So instead of having a kind of static sphere here, I want to have a sphere in each quadrant. And I can do that with a extract centroid. So now, just like that, without doing anything else, I have, let's see if we can visualize this. I have a point over there in each of these quadrants. I'm not sure if you can actually see that, but I do. So for each of these, I have a point, and I want to now dynamically reveal these points. So I can use another mops shape Falloff, and I'm going to just kind of center this here to my overall shape. So let's grab this to be a sphere in the center here. So I know that this is going to be my first point, and I can shrink this down, and then I can just scale this up, let's say over 75 frames, make this really big. And then I can use a blast, and what I can do here is just say add mops Falloff if it's bigger than 0.1, and it's a point group. So that's the opposite. So let's just switch this around so it's smaller than. There we go. So now I have the Falloff going. So this is going way too fast. So it's basically here's. So it needs to be 4. So I can set a keyframe, and I'm just going to override this one. All right. So let's just set this to be linear. And I don't think I need such a big Falloff. I think maybe that's why it's. Okay, so frame 48, it's still pretty much done. So let's change this keyframe to be 2.5. Okay, so yeah, that's better. I can set that in here now. Go back to frame 1 and hit play. And now I have this kind of infection solver updating and filling each section. So that was pretty cool. So let me just plug that into my out mops, and we can jump into our camera, highlight Vellum, and let's flipbook that and see what it looks like. All right, something I forgot to mention in this infection solver, it's not capped to 1. So you can see here that mops is actually going up to 66. So it's quite important that you come in here and just enable this remap so that it kind of fits this to 0 to 1. Otherwise you get these huge values, and because our Vellum solver is not clamping 0 to 1, it's taking the incoming value, it will just infinitely grow. So we obviously don't want that. So that's something very important to be aware of. So with that in mind, let's flipbook it. All right, so this is what we get with that. And although I kind of like the fact that it was a little bit more dynamic and you had all these individual ones growing, I didn't love the fact that it didn't look amazing. I just didn't feel like it looked amazing, especially these kind of start frames here. And so I then ventured into this one where we did the circular one, but something I did in the meantime was I changed the Vellum. So let's update the Vellum, and then we'll look at the last Falloff method, which is kind of the most complicated, and then we'll combine the two. So what I want to do now is I want to use Vellum pressure. So I'm going to just add in a Vellum balloon. Get rid of this cloth and use a Vellum balloon instead, just to get that nice squishy bouncy behavior. And I want to use my collider. After playing around for the settings, I used quite a high stretch stiffness just to kind of keep the balloon kind of nice and stiff. And then here I went quite low to get that nice bend again, and I increased the damping just a little bit. For the pressure, I went quite high as well. I went all the way up to 1 million, and I'll go with 3, and I'll increase the stiffness here, and we will increase the rest length. So if we hit play now, let's turn off the wind. We're not going to use the wind for this one. We'll keep the stretch stiffness, and we'll keep that. You will see that you get some crazy behavior where it just kind of goes wild. And the reason for that is we just have a single grid here, and we want to kind of add some geometry to this. So what I decided to do was kind of make this into little pockets of its own geometry. And the way that I did that, I'm going to give myself a little bit more space here. So the first thing I'm going to do is I'm going to use a transform, and I want to create little pockets. I'm just going to do this off to the side, and then we'll move it. And I want to use just these edges, and I want to move it backwards ever so slightly, maybe a value of 0.01. And you can see here that I'm just creating a little bit of a pocket. And then I can use a mirror node, and we need to make sure that I'm mirroring on the Z axis. And then we can move it back the same amount as this. So copy this parameter and paste a relative reference. Okay, so now we have this kind of cushion looking setup. The next thing I want to do is I want to make sure that I'm outputting this mirror group, and we're going to use that in the Vellum. Pipe that in here. Now everything is moving in the right place, and I have this geometry, but these pieces are now separate. So we need to make sure that we're fusing these pieces together. So we get this nice fuse, and good. And then what I want to do in this cloth is I want to make sure that I am pinning this edge group, but I also want to pin this entire back. I don't want it to be able to expand both ways. I just want to expand it forwards, and this is here just to give me a good pressure point. So I have this mirror group, but it needs to be a point group. So I'm going to do an attribute promote. Not an attribute, sorry, a group promote. And I will grab this primitive mirror group, and now I can select it over here, and now you can see the entire back is pinned but the front is not. So let's just take a quick look at what we're looking at so far. If I hit 1 frame forward, all right, so now we get this nice super squishy behavior, but again, this is not being driven by a fall off. Now the problem with a pressure constraint is if we do this same thing but with pressure. So we will keep it as is, and I'm going to set this to P stretch, and let me change my pressure to output a P stretch group, and we'll set this to 1. So what I'm going to do now is I'm going to drive this rest length inside this solver. This is pressure, and we're going to set this to 40. And then let's take a look at what we get if we do this. So I'll jump into my camera. All right, so I haven't simulated everything, but this kind of gives a good picture of what's going on. The first problem is that not everything's inflating, and when they do, it inflates all at once. You can see there's no fall off to this. It's just small or big. So there's no like gradual fall off. So what I wanted to do was to get a way to do that. And so I ended up not using this, but I ended up setting it here. So on the first frame, it will kind of inflate to its max, but then I ended up using a Vellum constraint, and I'm going to use a pin to target. And I'm going to set this to soft, match animation, and this value doesn't really matter because I'm going to set the stiffness inside here. So I'm going to duplicate this. I'm going to turn this one on, and this is going to be pin stiffness. And everything here can be the same. I need to set myself a group over here. So let's call this pin stretch. So now in this solver, I'm going to just run over the pin stretch group. And instead of writing the rest length, I want to write the stiffness value. And instead of writing it to be kind of compared to an original, it's just going to be set. So I know I want it to be very stiff when it's 0. It can be 10, and outside of that I want it to be 0. So basically once the fall off comes in, it releases the pins. That's what I'm doing here. So I could use a stopped attribute, but I prefer this one here, the soft one. It just gives a slightly cooler result. And something else before we resimulate, you can see here that you get this kind of weird behavior, and if you drop down a normal node, it does look a little bit better. But I found in rendering it didn't hold up, and so I ended up using a delta mush, but that makes it look very, very terrible. And what I want to use here is I want to do everything but the edges. So now I get this kind of really nice fall off where the edges are where they need to be, but I get this kind of nice gradual fall off where it's just smoothing out this border. And now post simulation, it looks a lot nicer. So this is without, and then this is with, and I just found that that gave a much nicer result. So with that, let's drop in our camera and then let's take a look at this. All right, so I didn't do the full frame range, but you can kind of get a glimpse of what that looks like now with this pressure, with the pins. You can see it's totally trying to inflate the entire time, but once the pins are released, then it inflates. You get a lot more organic kind of simulation. This jittering here is because of the collision of the bottle, and so you would maybe need to do slightly more sub-steps, and that's where also the velocity dampening would help. So while this velocity is really high, it would just kind of dampen it out and smooth it out a little bit, but then you get this kind of super cool behavior. So let's take a look at the very last part of this simulation where we're going to look at the outwards in simulation. So for this one, what I'm going to do is I'm going to just add in a few more points just so that we have more geometry to work with. And I'm going to increase this quite a lot just so we get this like really spirally looking look. Okay, let's go with 55. Okay, I think that's pretty good. Something else that you can actually do here is use an attribute remap. And I'm going to remap that mask attribute, and I'm going to remap it to density. And I can change here. So if we go into here and we set a density attribute, you can see now that I can change where I have the most points. So I can get more points in the center and not. This again is just kind of adding a little bit more control into the entire setup. And let's just turn all these into B-spline. And we can maybe have slightly fewer points again then. All right, so I think that looks kind of cool. It's a nice base. And then let's scroll down here. We will keep everything else as is, and we're going to talk about getting that fall off. Now, what I wanted to do here was I wanted to kind of grow it along. And the only way that I could figure to do this was to create a curve in the center of each of these and then animate that and then use that to drive my fall off. So again, I'm just going to delete all of this. I'll separate this node and let's start building. Okay, so I'm going to do it all the way before the remesh up here. So I'm going to drop down and I'll just so we can see it. And I'm going to use the labs skeleton 3D. Not 3D, 2D. I'm going to use the lab skeleton 2D. And if I pipe that in, you'll see there's an error. And that's because at the moment there's multiple shapes. And so I'm just going to use a for each connected piece. And if we have a look here, you can see that we have a different class attribute on each piece. And now if we pipe this in here, it does take a little bit to cook. What I'm going to do is just disconnect this, and I'm going to turn up this resample size to something quite high and plug it back in. This just makes it run a lot faster. Now, we don't have the greatest, let's look at here. We don't have the greatest curves, but you can see we get something pretty good. So let's drop this down to something a little bit higher. What I want to avoid here is I want to avoid these branching structures. It just makes it a little bit harder to clean up later. Now we can clean it up later, but I find it's easier just to clean it up here. So this one I think is okay. Everything else is fine. Okay, so we'll keep this as is. All right, so let's do a resample and we'll turn on curve view. I'll give these a nice amount of points just to kind of smooth them out a little bit. That looks pretty good. Then if we look at our primitive numbers, you'll see that some of these have 3. And so I'm going to use a fuse just to fuse any points that are not fused. And then I'm going to use a polypath. I always just like to kind of run this, just like I spoke before, I like to just run this over curves just to kind of alleviate any issues. And what I might just do here is just see what a clean does here. Okay, no, it doesn't do anything. Sometimes it'll like delete this point or primitive here, but for now it's okay. The next thing I want to do is I want to drop down a sweep and just see the orientation of these. So if I set this to round tube and I scale this, I want to make sure that these are all scaling in the same way. And you can see some don't have an orient, so I'm just going to drop down and orient along curve. All right, so now we have an orient. All right, so what I want to do now is I essentially want to grow these on like one at a time. And so I'm going to use a MOPS shape Falloff. I'll set it to spherical. We can just move this up and I'll shrink it down, set a keyframe at frame 100, just like before. We'll set it up maybe 2.5 and like that. Let's just see, it needs to get a little bit bigger. Okay, so I have that. And then if I do an attribute wrangle, what I'm going to do here is do a carve by Falloff. So what this is going to do is I'm going to use MOPS to kind of carve it. So if I use a carve node and I just plug this in and I look at it, I get this growing effect. But I want to drive this with an attribute, and you can't do that in the carve node. Hopefully side effects introduces that, but we can do that ourselves. So I'm going to just use a prim UV function, and that needs this UVW attribute. So I'm going to use the curve U attribute, and I'm going to multiply this by my Falloff. And the other two components will be 0. So basically I'm taking the 0 to 1 and I'm multiplying MOP. So as MOP comes through, it is giving this a value of 1. And then I'm going to create a grow vector. I'm going to set this to be prim UV, and this is how you write prim UV. I get my primnum, and then I'm going to use that UVW attribute, which is going to grow it. And then finally, I just need to set P to be this grow attribute. All right, so now you'll see that as MOPS is growing or coming through here, you can see it there, it's growing these pieces on. Let me just not see this. And you get this. Now this is inverted, and so I can flip this around. Okay, that's not what I want. So what I want to do is I want to start this really big. So I'll move this keyframe to the front and this one to the back, just to reverse the animation. And now I need to also reverse it in the remap here. So just set it like this. All right, so we get that. I'm not sure why I have that piece. Something else, we'll figure out that piece in a second. Something else to be aware of is that this doesn't delete the points. So even though here we don't have anything, it does still have points, and that's going to break it. And so we can here just do a blast node and just say that if MOPS Falloff is smaller than 0.01, then it'll blast them, and we can say points. And so now if we look at points, okay, we have 1 point here, and I think that's because MOPS isn't big enough. There we go. And so now it will slowly grow them on. And we do have changing point counts here. If that was a problem, we could fix it with a resample afterwards, or we could use a different method, not this method that we're doing here. But for what we're going to do, this is actually totally fine. So we'll keep it as is. So we get this cool growth. Now, something you'll notice is that these are all growing in a random direction, which is kind of cool, and it gives a cool result. But I wanted mine to all go in the same direction. And the only part of this whole process that is manual is this part, because I couldn't figure out how to do this in a procedural way, because I wasn't sure what would kind of dictate the way that we would show it to go in a specified way. So basically, if we have a look here, you can see the ones, I want them to go this way from left to right. So let's find one that's going in the correct way. So this one here is going in the correct way. And if you have a look at the sweep, the base is, the small part is here and the big part is here. That's why I added the scale. So we can see that most of them are the wrong way around. So all I'm going to do here is drop down a reverse node, and you can see it's swapped them all around. So now most of them are going in the right way. If I plug my reverse in, they would be. Okay, so most of them are going that way. And if we have a look here, we can see which ones are not, like this one here. And we can just grab another reverse, plug it in here. And what I want to do here is I want to select certain ones. And I'll actually do it like this. And select this. And now I can select all the ones, if it would just let me see it. There we go. Now I can select all the ones that are inverted. So I want the small part here. So I can just select that one. Those are right. I think that's all of them. And we can check it now with this and just see if they all are growing on in the correct way. Okay, this one is not. Neither is this one. So we can just jump back here. They should be. I selected them and I shouldn't have selected them. So you kind of just have to. You just have to make sure that you are selecting the right ones. Okay, this one is wrong. Okay, so you get the idea of what I'm going at here. I think I have all of them. Okay, that one's wrong. And I'll fix that one. And then I'll leave the rest. And you can play with them if you want. But let's just grab this one. Okay, so I'm going to say that this is good. And there's some funky stuff going on here. But again, it won't matter for what we're doing. So this is just a visualizer. Make it blue. Something you'll notice with this method, though, is that I'm not getting... Okay, this one is bugging me. Is that I'm not getting a perfect kind of one at a time growth. If you look at this, this one's growing before these ones grow. So it kind of breaks the illusion. And so I kind of set this up as a test and I figured it's pretty useful to have this. So I showed it here. But what I ended up doing was I used a different method. So what I'm going to do is I'm going to use a rest again, and we'll use another one to extract the rest. Afterwards, I'm going to use an attribute wrangle. Okay, and what I want to do now is I want to move these into kind of a linear line. And so what I want to do here is, actually, I won't do this section first. I'll show you. I want to do basically just at P, and I want to just set them to be f at curve u 0 and 0. So if we have a look here now, all these lines are packed from 0 to 1 because they have a 0 to 1 curve u attribute, 0 to 1, and I'm just moving them into 0 to 1 space. So you'll see here we have tons of points because we have tons of different lines that are all being stacked here. But now if I run a clip node, and I want this clip node to be on the x-axis because that's the axis that I'm specifying here. And if I move this, you can see now we get this same fall off thing that we had before. The problem with this though is it doesn't have a fall off. And so what we can do here is we can offset them. So let's just move lines. So that's what this float move is going to be. And I'm going to use our primnum. So each one of these lines has a different primnum. And I also want to give it a slight offset. So that's just going to be this channel here. And here I'm going to just plus move. So if I add this and I have a look at these lines, now as I move this, if I set it to 1, each one is moved, because if we have a look here, and we take a look at our prim nums, each one of these is a different prim num. So you can imagine that we're going to stack these 1, 2, 3, 4, 5, 6, 7. And as I move this now, and it would have to go quite far because there's 47 different pieces or something. And so this would have to go to 45, even higher, 50. Here we go. And if I move this down, you'll see that now we're going one at a time. And so basically what this is doing is we have all these lines here. Turn off prim nums. We have all these lines, and I have my clip node, and I'm just moving this clip node and eating away at these clips, or eating away at these lines. And what that looks like here is as I move this, it's going through and then it's just revealing them one at a time. But now obviously this again is pretty random, and I'm not getting, let's just get this in the right place. I'm not getting an outward growth. And so what we can do here is we can use a sort before I rest. And I want to set this here to be a proximity to point. And I know that this is about 0.5 up, and I want to reverse the primitive numbers. So if I have a look now at my primitive numbers, the outermost points, well, let's not reverse it. Now the innermost points should be 0, 1, 2, 3, whereas before they were kind of random. So there's 1, there's 2, but here's 40. So that's why it was random. Now I have an outward, and if I reverse it, the outermost points are 0 and the innermost points are the highest point numbers. So now when I stack them by this primitive number, I'll get the outermost points at the front end and the innermost points at the back end. So when we run this clip, we now get a proper outward inward growth. And I found that this worked super well. So in order to make this clip kind of more procedural, what I'm going to do here is do a bound, and I'm going to run that over these stacked points here. So like this, and I want to get the bounding, and I can use a sphere. I feel like I am the wrong way around here. Okay, I think this is right. Let's just double check where our bottle is. Yeah, okay, so I'm getting a bit disorientated in my scene. All right, so I have a bound, and this is now spanning the direction of this line over here. And I can use this, just drop down a null. I can grab this radar, and I'm going to, if you have a look at the detail attributes, it's giving me this radar, and that's how long this line is. So if we have a look at our grid over here, this is going to 51-ish or something. And if we have a look at this, this is 25.5 times 2 is 51. So that's what we want. And so we can then use that in here. And so I'm going to just use a detail expression. I want to go and find that outbound. I want to look up the radar function on 0.0, and I want to times it by 2. And then I want to just give it a little bit of a buffer. So I'll just say 0 like that, just so it's a little bit further than that. In order to now move this, I'm going to also kind of use a procedural expression where I'm going to fit the frame. This is just instead of setting keyframes, but it does the same thing. And I'm going to say maybe after 60 frames, we're going to go from 0. And now I can say I'm going to use the origin X. Okay. So what that means is now I'm going to take the origin. So it's going to end up at 0, and then it'll clip everything else. So it starts at 0 and then it reveals everything. And this is actually inverted. So I'll do it like, actually I can just change this to below the plane. So now it inverts it. And the reason this works is, let me just copy this and then delete this, is at 0, we know that this clip is at the end of this, because this origin is at the end. So we know 0 is that. Now we just need to move this to negative 51.255. And now it's at the opposite. So now this is at the origin. So to do that procedurally, we just take the frame number between these two frames. So we're going to go from 1 to 60. It's going to go from this and then to the same value that we've pulled in here, but the negative. So at frame 60, we have a 60. We now have the inverse of that. So that's how we get that to work. All right, so now we have this, and if we have a look here, now we get this cool, okay, well now it's the other way around. That's okay, we can just swap this here, reverse it, and now we get this cool outward in growth. Okay, so we have to keep going because obviously this isn't getting us what we want. We still need to get this to do something. And so what I want to do now is I want to grab my geometry, and I'm going to grab this here. I'm going to use a for each connected piece, plug this in. The one thing we need to make sure though is that in order for this to work, I need my connectivity to match on both of these. And so we'll check that at the moment. Let me just get this in the right place. Okay, so let's just take a look at connectivity, class attribute. Let's see if we have a class attribute already. We do. And then if we have a look here, we don't have a class attribute. So let's just figure out, did we ever have a class attribute? Here we have one, and is it the same as this one? No. It's not. So let's make sure that our class attribute is the same. So we can plug this connectivity into the remesh. All right, so we have the same one. Drop down here and double check that it's the same. No. Oh, we adding a new one. Let's get rid of that one. Okay, so far we good. We're good. Okay, so what that means is we have a connectivity and we lose it. Oh, this polypath loses it. And what we can do here is attribute promote this. So at the moment it's a primitive and this breaks our primitive. So we can just change this to a point attribute and then it will remain. And we have it here and it is now the same as these pieces here. So the colors are matching. Okay, so let's keep going with this. So what we want to do now is we're running over each of these pieces and we want to use a mobs object Falloff. You can use a different node and I'll show you why I like this mobs object Falloff for this. And what I want to do here is I want to do a VDB from particles. And we can just turn this down a little bit. I think we may need a bunch more points. So let's just drop a resample and we can just give it a lot more points. Yep, that's good. So now we get this super nice dense mesh here. Okay, so something like that. And if we plug this in here, the reason that I like this one is that it has a volume sample. So I can actually just read in a volume and it works. Let's get rid of this and let's check out our mobs Falloff again. This is again inverted. So let's reverse this. And I think the reason that it's inverted now is because I changed the class attribute, which does change things. Okay, so now, what is going on here? Okay, change it above the plane. Okay, now we have what we wanted. So the sort is on, not reversed, and the clip is above the plane. Okay, so that was a bit annoying, but now we've sorted that. And what we're doing now is we're just doing this VDB, and it's pretty fast. It's not slow at all, so it's quite fast to calculate. And if we have a look here at our mobs, it's not working. And let's see why. Okay, so our lines and our geometry are not in the same place. And that's because, remember, we're moving it with this match size. So let's just use a transform here. And let's just move all these lines forward 0.1 or 2. It doesn't have to be exact because this is so big and fat. So now you can see this. Now, the problem with the way that now that I'm showing you here, and the reason we're doing it in a for loop is that there's nothing to kind of keep it onto each piece. It's just going across multiple, and I didn't want that. So if we do it like this, it is still going across. And so what we want to do here is we want to make sure that we're only bringing in the line here that has the same kind of class attribute as this one. So we're only bringing in this line. So before we do this, let's move this up here. And what we want to do here is blast. And we want to blast. I'm going to create a for each metadata. Now this is going to give me an iteration. And so I can use that in here. So I can use a detail attribute. So I can say if at class is going to equal, and I can use this detail attribute again, and I'm going to go and find that for each metadata. I use iteration. So if it equals this iteration value, a little backtick, and let's just set this to primitive. We want to run over primitives, delete non-selected. So now that didn't work. Let me just make sure, I need to make sure that I attribute promote class back into primitives. We can just do it right at the end here, it doesn't matter. From points to primitive, grab class. Okay, so now we have our class attribute back, and now we're blasting the same one that we're running over here. Okay, so we just need to make sure we attribute promoted class here so that the polypath didn't delete it. So now we just attribute promoting it back so that we have it on the right attributes. Okay, so now we're blasting that. We have the one there. And if we have a look at mops Falloff now, you can see that it's constrained to each one. So now we're getting this kind of cool growth where it is growing on each one, and it needs to be a little bit thicker. So we can just come in here and increase the scale just so that it's growing in here like this. And now you can see that this Falloff is in fact growing inwards nicely. Now it's actually going backwards, and yeah, I showed you how you can fix that. So you can kind of go in there and change that. And all we have to do now is plug in the out Falloff. And what I'm going to do here is actually just do a clean. Except for mops Falloff. And then I just want to not visualize it. So let's just jump back into our Vellum solver, into our camera. All right, so something you'll see here is that it's kind of doing this weird thing, and that's because for some reason in this setup, I couldn't get it to work in a basic setup, but it's changing our primitive numbers or our point numbers along the way. And so I found the easiest way to do that was just to attribute copy this attribute back onto our original mesh. Okay, my computer was doing something weird, so I just quickly restarted Houdini. So what I want to do now is do an attribute copy, and I want to copy this onto my original mesh here, just so that I know that I have the right point count. But what you'll see here is if I copy the mops Falloff and I visualize it, let's just go forward a few frames, you'll see that I'm getting the same thing that we saw in my simulation, where it's not this. And that's because the point numbers are somehow being broken in this, which they shouldn't be, but they are. So yeah, let's just kind of work around it rather than spending half a day trying to fix that one little problem, which I did do, and I actually couldn't figure it out. So I worked around it. And what I'm going to do here is just use an enumerate SOP. And what I want to do here is just grab this index attribute, and then I can use this match by piece, and I'm going to say match by index. So you can see just like that, it's now using this because my point numbers change, but this index attribute doesn't. So now I can plug that in, and if we hold thumbs, this should do what we need. All right, so you get the base idea here where it's kind of this outward inward growth, and you can play with all the settings and kind of fine tune it, which is what I ended up doing. There's lots that you can play with here, as you've seen as I've built it. But I hope this kind of gives you a cool idea of how you can approach these different ways of doing fall-offs and different ways of doing inflations. You can try different ones on different setups that we've shown here, and you can see get a whole bunch of different ones. So this one was kind of long and there was a lot to it, especially this very last section, but I hope it was useful. I hope you enjoyed it. So I will see you again soon for another tutorial.